Hello, let's do the hypothesis test and confidence interval for proportion first. So let's imagine that out of, let's say, 127 students, 103 received A's in statistics. So this is a sample of people. What is the 95% confidence interval for the proportion of students that will get A's in my class? Imagine that out of 127 students, 103 received A's in my statistics course. What is the 95% confidence interval for the proportion of students that will get A's in my class? Well, for the 90% confidence interval, we're going to go into the student view here, and we're looking for a confidence interval for a population proportion given a sample size. So that's this one. So I said I wanted it to be 95%. The sample size was 127, and then the frequency of success of the A's was 103. So the confidence interval would be from 0.743 to 0.879. From 0.743 up to 0.879. So I would interpret this as I am 95% confident that the true proportion of students that will get A's in my class is between 74.3% and 87.9%. Now let's suppose we wanted to do a hypothesis test, right? It's pretty close to 75%. Let's say I think that more than 75% of my students will get A's. So in this case, my null hypothesis would be that the proportion is equal to, my H naught is that the proportion would be equal to 75%, and I'm going to try to make evidence of the alternative, which would be HA, which is P is bigger than 0.75. So again, go to the main page, calculation quiz 3, and here's the testing of a population proportion. So in this case, the sample still didn't change, right? Still 127 with 103. So sample size 127. This time for the proportion, we need the actual proportion. So I need to do 103 divided by 127. So for the population proportion, or for the sample proportion rather, I'll put 0.8110. 0.8110. The null hypothesis was I was testing it against 75%. And then if I want to be 95% confident, we have a 5% level of significance. That's the alpha level, or the chance of a type 1 error. So in this case, after computing, we end up getting a z-score that's not here, but we got a p-value at least, right? My p-value is a 0.0561 so 0.0562. 0.0562. P-value is 0.0562. So that means under the assumption that the true population proportion is 75%, I would expect to get a sample of 127 with 103 A's, only about 5.62% of the time. This is rare, but it's not rarer than 5%. So I would probably say in this circumstance, I would fail to reject H0. And I would say, I do not have evidence that the proportion of students that get higher, or A or higher, that get A's in my class is greater than 75%. I do not have enough evidence to be able to conclude that, at least based on this sample. It's close, but it's not quite rare enough for me.